Yellowstone National Park is world famous for its supervolcano. But beneath its surface, there's a secret geothermal world that no one really knows about. Here are some of the most incredible places in this park that aren't even close to the volcano. Yellowstone is full of surprises, and it doesn't just have to do with the supervolcano underneath it all. Yellowstone hides many secrets under its surface, but they're not as dangerous as the volcano. So what are these mysterious features? Why don't we know about them? And how did they form? That's what we'll explore today. The Yellowstone supervolcano is responsible for creating the Yellowstone caldera, which is also known as the Yellowstone supercrater. This crater has a diameter of 43 by 28 miles, making it almost the size of Los Angeles. It was formed after the three major eruptions of the Yellowstone supervolcano between 2 million and 630,000 years ago. The reason why this is important is because large volcanic eruptions can cause massive climate change. For example, the 1815 eruption of Mount Tambora in Indonesia caused the year without a summer in 1816. The amount of ash and gases released into the atmosphere blocked the sun's rays and plummeted global temperatures by around 2.5 degrees Celsius or 7 degrees Fahrenheit. However, despite being a supervolcano, the Yellowstone supercrater isn't the most interesting thing about Yellowstone National Park. And that's not just because there are a lot of other cool things about the park. It's also because the Yellowstone supercrater isn't even close to some of the most exciting features of Yellowstone National Park. To put that into perspective, the Grand Prismatic Spring is much closer to the city of Casper, Wyoming, than it is to the Yellowstone supercrater, and that distance is around 110 miles. Meanwhile, Old Faithful is even closer to the town of West Yellowstone, Montana, with a distance of only 9 miles. And yet another great example is the Mammoth Hot Springs, which are located 46 miles away from the Yellowstone supercrater. These are just 3 examples of many fascinating features of Yellowstone National Park that are quite distant from the supervolcano. Now let's talk about the formation of these features. In order to understand how these amazing places were formed, we need to look at what's happening beneath the surface of Yellowstone. Beneath the park, there's a magma chamber filled with molten rock that's heated by the Earth's core. The heat from the magma chamber radiates outward in all directions, creating a dome of hot rock called a magma plume. This magma plume is the driving force behind many of the park's geothermal features. As the heat from the magma plume reaches the surface, it creates areas of intensely hot water. This water can reach temperatures as high as 200 degrees Celsius or 392 degrees Fahrenheit. The heat from the magma plume is so intense that it actually melts the rock beneath Yellowstone, creating huge underground rivers of molten rock. This molten rock is what eventually creates the Yellowstone supervolcano. However, not all of the rock melts. Some of it turns into a substance called peridotite. Peridotite is a type of rock that's found deep within the Earth's mantle. It's typically only found at depths of 60 to 200 miles below the surface. But in Yellowstone, the heat from the magma plume has melted it near the surface. As the peridotite melts, it creates pockets of space for water to trickle down into. The water then becomes superheated and creates hydrothermal activity on the surface. This hydrothermal activity is what creates many of Yellowstone's most famous features, including the Grand Prismatic Spring and Old Faithful. But these features aren't created evenly across the park. They're only found near the edges of the magma plume. This is because the heat from the magma chamber is too intense to support life. Only the areas on the outskirts of the plume are cool enough to support bacteria, which is the foundation of the food chain for the brightly colored algae and other organisms that create these beautiful features. Yellowstone National Park is home to a variety of colorful hot springs and geysers, but none are more famous than the Grand Prismatic Spring. Located in the Midway Basin, this massive hot spring is the third largest in Yellowstone and is renowned for its vivid rainbow colors. The colors are caused by different types of bacteria that live in the hot spring. The bacteria use the heat from the spring to create energy, and the different colors are based on the type of bacteria. The most common type of bacteria in the Grand Prismatic Spring is called cyanobacteria. This bacteria is blue-green and creates the characteristic turquoise color of the spring. However, there are also other types of bacteria that create yellow, orange, and red colors. These bacteria live in the upper layers of the spring, where the water is cooler. As the water temperature decreases, the bacteria begin to die and turn the water their own color. The Grand Prismatic Spring is named for its rainbow colors, but it's also named for its shape. The spring is roughly prismatic in shape, meaning that it has a triangular shape with flat sides. This is due to the fact that the spring is located in a tectonic plate boundary. The movement of the plates has created a series of cracks and faults in the area, and the Grand Prismatic Spring has filled one of these faults. Moving on to another iconic feature of Yellowstone, we have Old Faithful, the world's most famous geyser. Old Faithful is located in the upper geyser basin and is known for its regular eruptions that can shoot water up to 185 feet into the air. What makes Old Faithful so unique is that it's the most predictable geyser in the world. Eruptions occur every 90 minutes and last for 1 to 2 minutes. The predictability of Old Faithful makes it a popular tourist destination, and it's estimated that over 10 million people visit Old Faithful each year. But the reason for Old Faithful's predictability is actually quite simple. Old Faithful is connected to a network of underground pipes, and these pipes allow water to flow from the magma chamber to the surface. The water in the pipes heats up until it reaches its boiling point, and then it erupts. The predictability of Old Faithful comes from the fact that the water in the pipes has nowhere to go except upwards. This means that the pressure from the magma chamber is constantly building up until it reaches its breaking point, and then Old Faithful erupts. Finally, we have the Mammoth Hot Springs. Unlike Old Faithful, the Mammoth Hot Springs are not a single feature, but rather a collection of hot springs that are located in the northern part of Yellowstone. The Mammoth Hot Springs are made up of several terraces and platforms that have been created by the deposition of calcite and other minerals. The hot springs are a popular tourist destination, and visitors can walk along boardwalks that have been built over the springs to get up close views. But unlike the Grand Prismatic Spring and Old Faithful, the Mammoth Hot Springs aren't caused by bacteria. Instead, they're caused by the deposition of minerals from the water. As the hot water from the springs flows over the rocks, it dissolves the minerals and then deposits them on the surface. This creates the terraces and platforms that are so unique to the Mammoth Hot Springs. Each of these features is unique and special in its own way, but they all have one thing in common. They're all powered by the heat from the magma plume beneath Yellowstone. The magma plume is the driving force behind many of Yellowstone's most famous features, and without it the park wouldn't be the same. But these aren't the only geothermal features in Yellowstone. In fact, there are hundreds of geothermal features in the park, including mud pots, fumaroles, and more. Many of these features are similar to the ones we've already discussed, while others are truly unique. One of the most mysterious features in Yellowstone is the great fountain paint pots. These bubbling mud pots are located in the Black Sand Basin and are known for their strange bubbling activity. The paint pots are created by the buildup of gases from the magma plume, and when the gases reach their breaking point, they erupt and create the bubbling activity. Another unique feature in Yellowstone is the Steamboat Geyser. Located in the Norris Geyser Basin, the Steamboat Geyser is the tallest active geyser in North America. The geyser erupts every few minutes and can shoot water over 300 feet into the air. The reason for the geyser's height is due to the fact that it has a superheated steam chamber. But these are just a few examples of the many geothermal features in Yellowstone. From the colorful Grand Prismatic Spring to the unpredictable Steamboat Geyser, Yellowstone is home to a wide variety of geothermal features that are sure to amaze. So next time you think of Yellowstone, don't just think of the supervolcano. Think of all the other amazing features that make this park so special. Don't forget to like this video if you learned something new and subscribe for more science videos.